channel?
Yes, we can.
Okay, so just know that the record is, the lesson, it is recorded and it might be published on YouTube. So sometimes you might see the same lesson, even for yourself, for revision sake. Okay?
Okay. Yes.
Yes. So, and the other thing is that I normally pray before I start my lesson. Do you allow me to pray?
Yes, I do.
Okay, so can we close our eyes? Father, in the mighty name of Jesus, Lord, we thank you for this wonderful day. Father, thank you for this new learner, Umfuna. Father, I ask for wisdom. Father, I ask that may you please help me in the mighty name of Jesus to tailor the lessons according to her abilities, Father. In the mighty name of Jesus, Father, may I not rely on my own understanding. May I not rely on my experience that I've been having teaching different learners. But Father, I ask for the fresh wisdom from you in Jesus' mighty name. Father, may I be understood. Father, I also pray for her that may she be keen for her books. May she fall in love with mathematics. Father, if mathematics used to be a subject that bothers her, today I pray that, Father, may she develop love for this subject. In Jesus' mighty name, we give you honor and glory. Amen.
Amen.
Oh, okay. I'm just gonna share my screen and you confirm if you see it. Can you see my screen?
Not as
Um,
yet. Oh, yes, I can.
you can see my screen, right? So
Yes.
I have prepared so you are on a laptop, right?
Yes, I am.
Okay, so I'm just gonna go for portrait so that um it can accommodate you. No, the landscape, what I meant to say. Uh Tell me if it's visible enough.
Yes,
Is
it
it
is.
okay? No, thank you. Um, okay, so like, which school do you go to?
I'm in Pretoria High School for Girls.
You okay? Uh, Pretoria Girls. Hi. Uh, okay, that's wonderful. Okay, then yeah, we can definitely go for our lessons. Okay, Omfuna, please. I'm gonna ask questions, and then where you know, please answer me. Where you do not know, let me know that you do not know. Okay, let's interact. Okay, so I just want to
Okay.
ask you a simple question. What do you think it is a number?
A number.
Hmm.
I'm not quite sure.
Okay. Can you try to answer it like? Can you say what you think in your mind? If someone says a number, what comes to your mind?
I guess a sequence.
A sequence. Okay. Another term right there. Okay, is A number?
No,
What is it?
a letter.
Okay, what about this one? Is this a number? What do we
No,
call
it is
this
not.
thing? What do we
It's
call this thing?
pi. Pi.
But then can I argue that it is a number because of this thing? It is the same as 3,14 something.
I believe so, yes.
Okay, so a pi it is a number, right?
Okay, yes.
Oh, okay. So what about square root of 2?
Yes, it is a number.
It is a number.
Yes.
Okay. No, cool. So at least we know what is a number. We know what is not a number.
Yes.
Okay.
Yes.
So even though we do not know the description of a number, but then we know what is a number, we also know what is not a number.
Number.
Okay. So this
Yes, sir.
topic, it is very important because of your grade 10. We are in grade 9 now, right? Your grade
Yes, sir.
10, question 1, your exam, it will be based on this topic. So meaning that next year in grade 10, they're just going to do a reminder of this work and then know that the first question in grade 10, it is about this number systems. Okay. So
Yes, sir.
I'm just going to try to move where I'm fast, where you miss something, just ask, okay, or just stop me. So
Okay.
we have got a number system, okay? A number
Yes, sir.
system is a system that consists of different numerical values, okay?
Okay.
So like for instance, like we have a family of numbers, okay? If I ask you
Okay.
that, tell me any number, you can say 1, it is a number. Someone will say 2. They are both right. Other one can just say pi, like I did earlier on. It is a number, right? Because we know that it has a numerical value of 3,14. Okay.
Yes.
So, but then now these numbers, they have categories.
Okay.
Okay. And then
Yes, sir.
in this lesson, I intend to discuss 8 categories of numbers. You see, I have a summary here. 5 of them. Here it's 5, and then we're just gonna finish up with another 6 and 7. Okay, and then
Yes,
from
sir.
there, we'll definitely have homework on this. You should be understanding after we have done this lesson. Okay,
Yes, sir.
so now we have got different types of numbers. They've got families. It's like us people, like we are all human beings, but then
Okay.
we have different tribes. If I can
Yes.
get to your class and say, "Yenda, kabata kuwe ngamlenje," like perhaps it is only vendors who are going to stand up, right?
Up. Yes.
And then ka fitlha ka re ra locha emelang go ile go emela batho ba ba feng ba page. Okay, so even numbers, they have categories. We classify them in different categories. Okay, so
Yes, sir.
now let's start. So we have got natural numbers, and then they are being denoted by that symbol n. Can you see n there? Can you see this?
Yes. Yes, sir.
N. Okay, so those are our natural numbers.
Numbers.
Yes. So now, whenever we talk about natural numbers, natural numbers. Okay, so Omfuna, whenever we talk about natural numbers, we talk about 1, 2, 3, 4, and 5.
5.
Okay, so these numbers, they exclude 0. Remember, 0, it is a number.
Yes.
Right? 0, it is a number.
Number.
But then when we talk about natural numbers, we do not count 0. So it means that 0 will be unnatural. Okay, so any number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you can count up until infinity. They are natural numbers. So when I mean that they exclude 0, I do not mean that this one from 10. I simply mean that they do not start from 0. You know, sometimes when they say count, sometimes you can start from 0 and you say 0, 1, 2, 3. Okay, but then what I simply mean is that you've got tens, you've got hundreds, you can have 1,000. So when I mean that they exclude 0, I do not mean that you do not have 10, you do not have 100, you do not have 1,000. I mean that you do not start at 0, but you start at 1.
1.
Okay, those are what?
Yes,
those are natural numbers. Okay, like I said already, that they are being denoted by n. Simple as that. Right?
Yes,
and after natural numbers, we have got what we call whole numbers. So now whole numbers, this is where now we involve 0.
Okay.
A whole numbers. So with whole numbers, now the 0 is involved. I will say that you can even remember that the sign of whole numbers, it has this. So you can remember that, okay, this subscript it means that the 0 now it is included. So basically, the whole numbers are the natural numbers, including 0.
0.
Yes. So 0, 1, 2, 3, 4, and 5, and so on
5.
and so on. Okay. So
Yes,
now notice that the numbers can belong to more than one category of numbers. Like for instance, if I
Yes.
ask you about 1, it is a natural number. It is also a whole number. But then when I ask you about 0,
Yes,
it is not a natural number, but then it is a whole number. So notice that they can belong to more
Yes.
than one group or one class.
One category.
Are we together? So now
Yes,
we
sir.
are coming to this one. Mathematicians like these numbers. I cannot emphasize how much they like these numbers. So you will see when you go to grade 10, grade 11, and grade 12, they always ask you the question and say that it is element of integers. Okay? So meaning that if you get a number which is not an element
Yes,
of
sir.
integers, you do not take it as an answer. So they ask you a question and say that you must give them an answer which is an element of what? Of integers. Okay,
Integers.
so now let us talk about
Yes, sir.
integers. Please, this is my favorite set of numbers, by the way. Integers. Okay, integers. And they are being denoted by this beautiful Z. Is it Z or Z?
It can
Omfuna?
be either one.
How
Yes,
do you
sir.
pronounce it yourself?
Sir?
What do you call it yourself? Do you call it a Z or Z?
A Z.
Okay, no, it's fine. So these are the integers, and they are being denoted by this sign of what? Of Z.
The Z.
Okay, so now the only special
Yes,
thing
sir.
about this one is that these numbers include negative numbers. So you can start from
Okay.
infinity and then you have -3, -2, -1, 0, 1, 2, 3. Okay, so these are
Yes, sir.
integers.
Integers.
Yes. How are integers different from whole numbers, if I ask you? No, from
Whole number.
the natural numbers. Let me ask you about the natural numbers. How are
Integers are
different from-
different. Integers are different from natural numbers because they also include 0 and negative numbers.
Wow, that's wonderful. Okay, they include 0. I like the first point. If I were to mark, I was gonna give you a mark that they include 0. And then we all know that the natural numbers do not include the 0. They also include the negatives, which the natural numbers do not include. That's what. Okay, so far we spoke about 3 of them. Okay, can we go to the 4th class? So on the 4th class, we have got the numbers that we call rational numbers. This one they scare learners. I don't know why. I don't know why learners always get scared of these numbers. Rational numbers. So whenever we talk about rational numbers, these are the numbers which are not whole. Okay, like for instance, if you check the numbers that we had, okay, let's check the numbers that we always had. You see, it was 0. We did not have a comma. We did not have a line below. We did not have radical signs. Whenever I talk about radical signs, I'm talking about the root signs. Ne? This is a radical sign. Ne? You know it, right? They call it a square root. This one, right?
Yes, sir.
So, all these numbers that we spoke about, Omfuna, they didn't have funny signs. Okay, there was no point where we had 0.3, 5, 5, 5, 6, 7, or where you would get over 5. You see, These are the two numbers. The other one
Yes,
is
sir.
on top of each other. With the three types of numbers that we spoke about, we have never encountered this.
Yes, sir.
Okay?
Yes, sir.
So now, rational numbers. These are the numbers that include fractions and decimals. What are they?
They are the numbers that include fractions and decimals.
Yes, fractions and decimals. Do you know what do I refer to when I say decimals? Do you know what is a decimal?
Yes, I think so.
What is a decimal? Can you give me an example of a decimal?
0.12.
Yeah, it is a decimal because of it has a comma. And a fraction?
A fraction 1/2, also known as a half.
Yes, also known as a half. Okay, let me try to trick you. Let's just go away. Okay, if I give you 6/3. Is this a rational number? A whole
Yes.
number or a natural number?
It
Integer?
is
What kind of a number is this? It falls under which
a
categories?
rational numbers.
Okay. Is it an integer?
No,
Okay. Is it a whole number?
no, it's not.
Is it a natural number?
No, it's not.
I would like it to bring it to your attention that it is all of those.
Oh,
You know what is my reason?
no, sir.
Is my reason. 6/3 is how much?
It equals to 2, if I'm correct. Yeah. Oh.
So natural number.
Oh,
You
so
get
it's
it?
a natural. Yes, I do.
It is a natural, it is a whole number, and it is an integer. But then it is written as a rational number because of they have made it a what? A fraction.
Fraction.
Okay?
Yes, sir.
That's wonderful. So, but then there is something that I want to talk about. 3 divided by 0.
It's undefined.
Yes, it is undefined. We can never divide by 0, ne?
Yes, sir.
So is this a whole number?
No,
A rational?
no,
An integer?
no.
Not even a natural number, right?
Yes, sir.
Okay, cool. So let us continue. So these are our rational numbers. We said that our rational numbers are fractions and decimals.
Decimals.
Right? And then now, how do we denote the rational numbers? What is the sign for rational numbers? It is this Q, ne? You have a Q like this. Let me try to draw it neat. So it is something like that, ne?
Yes, sir.
So this is what? Your rational numbers. Okay? So
Yes, sir.
now whenever we talk about rational numbers, Umfuna, you should be careful that our denominator. Do you know what is the denominator?
Yes, sir.
What is a denominator?
The number at the bottom of a fraction.
Aha, it is a number at the bottom of the fraction. I'm happy about your foundation. You have a solid foundation. So our denominators, whenever we talk about this, our denominators shouldn't be 0. Okay, can never be equals to 0. So you must note well. Whenever you are dealing with what?
Yes, sir.
Whenever you are dealing with fractions, they are irrational numbers.
Yes, sir.
Okay. Any question up to so far?
No, sir.
Okay, let's continue then. So then now, whenever we talk about this, oh, sorry about that. Can you still see my screen?
Yes,
Omfuna?
yes, I can.
Okay,
Yes, sir,
that's
I
right.
can.
Okay, thank you. So now, the rational numbers, they include all the integers, right? So
Yes, sir.
under rational numbers, we have all the integers. So now
Integers.
let us add more information here. Remember, we are still under rational numbers, ne? So
Yes, sir.
they include integers, right?
Yes, sir.
And they also include all proper fractions. Do you know what is a proper fraction?
I think so, sir.
All proper fractions. Okay.
Yes, sir.
What is a proper fraction?
A fraction where the numerator is smaller than the denominator.
Yes, the numerator, it is smaller than the denominator, meaning that it is proper for a bigger number to carry a smaller number.
Yes,
Okay,
sir.
but it does not end there. It also includes the improper ones. What are the improper fractions? You know them, right?
Yes, sir.
Yes, it includes the improper
Improper fractions.
fractions. It also include, now I am going to talk about something which might be new. We haven't mentioned it up to so far. Okay?
Yes,
So
sir.
I'm gonna talk about the terminating decimals.
Okay.
Do you know what is a terminating decimal?
No, sir.
Do you know what is a terminating decimal?
No,
Okay, I'll
sir.
explain that to you now. Terminating decimals. Okay, so terminating decimals, Umfuna, those are the decimals the decimals are not that long. Okay, like for instance, we can have a decimal like this: 0.1, 2, 3, 4, 5,
Excuse
6,
me,
7,
sir.
9. Can you hear me?
Barely, sir. The line is cutting a bit and it's also frozen the screen.
The screen is frozen. Is it still frozen?
Yes, sir.
Let me see. Let me see.
It's probably my line. Okay. Yeah, I can see it now.
Is it moving because of I'm moving it around?
Yes, sir.
Okay. So I wanted to explain what are the terminating numbers, right?
Yes, sir.
So the terminating decimals, Umfuna. You see this decimal. Is this a decimal?
Yes, sir.
Yes, it is a decimal, ne? But then it is very long. So normally the terminating decimals are the decimals which are very short. Those are the terminating decimal.
Yes, sir.
Okay, like if our decimal were to end here, you see it has only four. It has four what?
Digits.
It has four numbers after the comma. So it is the terminating decimal. But then once it becomes long like this, it is not terminating.
Yes,
Okay?
sir. Yes, sir.
So the word terminate, it is an English word that simply means to stop. Right? So
Yes, sir.
basically, it is a decimal that stops quicker than this very long. It's not the same as this long decimals.
Yes, sir.
So do you understand what are terminating decimals?
Yes, sir.
E.g., can you give me an e.g. of a terminating decimal to show your understanding?
I beg your pardon?
Please give me a terminating decimals.
0.78.
Can you please mention a terminating decimal? I'm asking for an example of terminating decimal here.
0.78. 0.78.
0.78. It is terminating because of it has only 2 digits after the comma.
The comma.
Okay. Yes, that's wonderful. So now I move. We all understood what are terminating decimals, ne?
Yes, sir.
Hello.
Yes, sir.
Hello. Can you hear me?
Yes, sir, I can.
Okay, so now we also have another category. Please don't forget that we are rational numbers. So it has so many branches. We also have what we call recurring decimals. This is another type of decimals.
Recurring decimals, okay.
Recurring decimals. So, Omfuna, what are recurring decimals? Do you know what are recurring decimals?
I think so.
What are they? How would you explain it to me? Let me say that I'm a learner and you are a teacher. Ma'am, what are decimals?
Recurring decimals are decimals that repeat the same pattern.
Exactly. I like the word repeat and the word pattern. Okay, so they repeat the same pattern. Okay, so it is there is a pattern or a trend that can be spotted. Like for an example, e.g. 0.67676767. Okay, so and this we normally write it as in 0.6 dot there, 7 there.
7 dot, yes, sir.
Yes. So those are the recurring decimals. Okay, and the terminating decimals. Okay, so I hope you're not gonna forget this.
I won't.
Okay, so the other thing that I want you to note, like I always mentioned it, that note that rational numbers include the integers, right? And therefore also the whole numbers, natural numbers, all integers are also rational numbers. Basically, everything that we spoke about up until so far, whole numbers, natural numbers, integers, all of them, they are included whenever we talk about rational numbers. So rational numbers, it is an umbrella that has so many branches under it.
Yes, sir.
Okay. Hello.
Yes, sir.
Omfuna, are you there?
Yes, sir, I am. The line is just cutting a bit.
So those are the numbers that I wanted us to talk about. But then are we done? No. You. Sorry about it. Okay, but now is it audible?
Yes, sir.
Hello?
Yes, sir, it is audible.
Okay. So I'm almost done.
Yes, sir.
Okay, I'm almost done. So I want to talk about the irrational numbers.
Yes, sir.
Okay?
Yes, sir.
I want to talk about the irrational
numbers.
Okay? So whenever we talk about irrational numbers, we spoke about rational ones, right?
Yes, sir.
So whenever we talk about irrational numbers, let me put it here. Irrational numbers. And then do you know the symbol of irrational numbers?
Yes, sir.
It is a Q, right?
Yes, sir.
That has that. Okay, so these are the irrational numbers. So whenever we talk about the irrational numbers now, Mfuna, these are the numbers that we did not include when we were talking about rational numbers. So remember, whenever we were talking about rational numbers, we spoke about the terminating numbers. So now where do the non-terminating go? This is where the non-terminating comes. Non-terminating. So meaning those long decimal numbers, they are what? They are irrational.
Yes, sir.
Okay?
Yes, sir.
What about the non-recurring decimals? Non-recurring decimals are also irrational. Non-recurring decimals are also irrational. Okay, so we spoke about two. And then we also have the square roots of numbers that are not perfect squares, cube roots of numbers that are not perfect cubes. Here, there's a lot of mathematical language. Okay, we have what? The squares that are perfect squares. Do you know what is a perfect square? You are name few perfect squares?
It can be 9 squared, 4 squared, 16 squared. I think 144 squared, 121 squared. Yeah.
You have a clue, but I just want to polish whatever that you are saying. Eh?
Yes,
I just want to have an image on that. Square roots of numbers that are not perfect squares. And cube roots of numbers that are not perfect cubes. Okay, so now our lesson will deviate a bit. I spoke about perfect squares here. Okay, so our lesson is going to deviate. We spoke about the square root. You know the square root, ne? Cube root, and perfect cubes.
Yes, sir.
Okay, so we need to understand what are really this. So, number one, square root. We all know that.
Yes, sir.
This is the square root. Okay.
Yes, sir.
Number two, cube root. How do we write cube root, Omfuna?
We write it with the symbol, but we add what's this? Exponent 3 on the root.
Yes, the 3 on the tail, ne?
Yes, sir.
On the tail of the radical sign, like that. That is a cube root. And then now, okay, this is where I wanted to polish now. So we spoke about perfect squares. Okay, so
yes,
I'm gonna give you perfect squares, and then I'm gonna tell you how we made them. Okay,
yes, sir.
So our perfect squares, it is 1, 4, 9, 16, 25, 100. I jumped. 25. Is 36 a perfect square? Yes.
Yes, sir.
36, 49, and so on, right?
Yes, sir.
These are the perfect squares. Why do they call them perfect squares? How do you get
Because
them?
they're when you times what's this? One of the numbers with each other, it creates the answer, I think.
It creates a perfect square. That's wonderful. You times a number by itself. 1
Yes,
times
sir.
1, you get 1. 2 times 2, you get
So
4.
4,
3 times 3, you get
9.
Omfuna, are you there?
Yes, I am.
3 times 3, you get 9,
9.
right?
Yes, sir.
And then 4 times 4, you get 16.
16.
Yes. So you understand the perfect squares, ne? They
Yes,
are
sir.
very, very, very important. They are very, very important because of I think it is this year where you are going to learn the difference of uh the difference of two squares.
Sir.
Okay, and then if you do not understand this, then they will dribble you. So if you understand this, then we will definitely flow. So let us talk about perfect cubes now. What are perfect cubes?
Let me see. 27. Oh, no. 8.
Let's
There's
start at
8.
1.
Okay, sorry.
Mm-hmm.
1,
1, 8, right?
8,
Mm-hmm.
27,
Yes. 20,
64.
64. Oh, another secret number. How can
Yes,
I
sir.
write it down? So 64, it belongs to both of them. It is a perfect
Yes.
square. It's also a perfect
And
cube.
yes, sir.
Yes. So, okay, and so on, right?
Yes,
As long
sir.
as you know how to get them. So now, if you see a number that is not a perfect square under a square root, then you know it will cause irrational. It will make things to be irrational.
Yes, sir.
So meaning that under a square root, we must have a what? A perfect square for it to be rational.
Yes, sir.
And under a cube root, we must have a what? A perfect cube for it to be rational.
Rational.
But any number under a cube root, which is not a perfect cube, it will make things to be irrational.
Yes, sir.
Okay.
Yes, sir.
Yes, that's wonderful. So now we know irrational numbers, and then
Yes, sir.
our special number, our beautiful number here. Oh, also pi, brother
Oh,
pi.
yes.
Brother pi is irrational as well, ne?
Yes, sir.
Okay.
Yes,
We
sir.
have, oh gosh, Omfuna is still there?
Yes, sir.
I think the network is beeping here. So we have pi. Pi, it is also what?
Irrational.
Irrational. Okay.
Yes, sir.
Yes. So, okay. So I think we have discussed this. Let me check my summary that I have prepared. Oh, okay. Then from there, we have got real numbers, number 6. We are almost there. Just be patient
Yes, sir.
with me. We have got number 6, and number 6 talks about real numbers, right?
Yes, sir.
So any number on the number line, it is a real number. All rational and irrational numbers
Irrational.
put together. Omfuna,
Yes, sir.
are you there?
Yes, I am.
So now I'm talking about a very, very big umbrella here. I'm talking about real numbers,
Yes, sir.
right?
Yes, sir.
And they are being denoted by this R. What is this sign for?
Real numbers.
What is this sign for?
Real numbers.
Real numbers. So
Numbers.
now, under real numbers, let us make a, a, a tree. Under real numbers, Humfuna, we have this. And we also have this. What are those ones? What is this?
Irrational and rational numbers.
Yes, irrational and rational numbers.
Rational numbers.
So now let us go for rational numbers. What do we have under rational? What can I list under rational numbers?
I beg your pardon?
Which numbers do we have under rational numbers?
We have 0, 1, 2. Oh, sorry. We're on rational, right, sir?
Yes, rational.
We have decimals and fractions.
Decimals and fractions. What are decimals and fractions?
A
So
fraction.
under this one, we have whole numbers. Do you
Yes,
agree
sir.
with me?
Yes, sir.
We've got the natural numbers. Okay, let's start with natural numbers. Right? Natural numbers fall under rational. Right?
Yes, sir.
What about whole numbers?
They also fall under rational.
They also fall under rational. What about integers?
They also fall under rational.
Yes. And what else? What are we forgetting here? Oh, these are the three. Eh?
Yes, sir.
I think they are only three. Right?
Yes, sir.
Okay. We forgot the recurring and the terminating.
Oh, yes, the recurring and terminating.
Recurring. Here, terminating. Okay. Then now, under irrational, mostly it is the things or the opposite of the things which are under rational. Okay,
Yes, sir.
let's start. On that side, we had terminating. This side, we will have non-terminating.
Yes, sir.
Okay, non-term. That side, we had recurring. This side, we will have non-recurring.
Non-recurring.
Recurring. Okay?
Yes, sir.
What else? So we are under irrational, right?
Yes,
We
sir.
have non-terminating, non-recurring. Okay, let's bring our brother Pi. Okay, and then
Yes, sir.
remember, for this one, I'm just gonna use this so that you can remember. I'm just gonna use the square root of a number which is not a perfect cube, and then a cube root of a number which is not not a perfect square.
Yes, sir.
And a cube root of a number which is not a perfect cube. Okay, so
yes, sir.
If you can understand this summary, you see it's a very nice summary. You start by saying that all of these things that we spoke about, they fall under real numbers.
Yes,
and then under real numbers, you've got two branches, which are rational and irrational.
Irrational numbers.
And then under irrational, you've got how many branches? 1, 2, 3, 4. You've got 4 branches. Even under your rational numbers. Oh, under rational numbers, you have 5. And then under irrational, you have 4.
4.
Okay.
Yes, sir.
So far, do you have any question? I'm almost done.
No, sir.
Okay. So now, I want to talk about non-real numbers, but then I'm not going to dwell a lot in it, but then I just want to make justice to it as well.
Yes, sir.
Okay. So whenever we talk about non-real numbers, non-real numbers. Those are your error, where your calculator gives you error or undefined.
Yes, sir.
Okay?
Yes, sir.
So there's a point where I asked you a question and you said that it is you said that it's a math error or you said it's undefined. Do you remember what was the
Yes.
question? What did I
It
ask?
was, you asked, is 3/2 a proper fraction?
Yes, but then you said that this. Yes, I did ask that, but then there was a point Funa, where you said that it's not defined by the calculator.
Oh, yes, sir.
What was the question? It was dividing by 0, right?
Yes, sir.
Yes. So division by 0, it is non-real.
Yes, sir.
Number 2, this one, it only lasts up until high school. When you do mathematics calculus in university,
Yes, sir.
second year and third year, I think, you are going to be able to define this. Okay, square roots of negative numbers. Okay,
Yes,
square
sir.
roots of negative
Numbers.
numbers. So remember, this one will carry you up until you finish high school. Ne? In
Yes, sir.
university, in tertiary, we call them complex numbers. So it is defined. Okay?
Yes, sir.
So Umfuna, any question about this? I think I did justice to number system, all of it.
Yes, you did, sir.
So yeah, then now we might need to answer questions and see if you really understood this. Okay, so I think I have passed the exercise. Okay, so this is your exercise, ne?
Yes, sir.
And I'm gonna send it to you. I'm gonna send it to Daddy. Daddy will give it to
Okay.
you, and
Yes,
you
sir.
need to complete it and submit it before tomorrow 8.
Yes, sir. 8 p.m. or 8 a.m.
Is it possible?
Yes, sir.
8 p.m.
Sir, okay.
Okay.
Yes, sir.
Yes, and I'm gonna schedule, and then I'm gonna talk to Daddy when is our next lesson. But by next week, you will have a fixed schedule. Okay. Now, this week, things were just abrupt.
Yes, sir.
But then by next week, everything will just be in order. I'll tell you when are your lessons. I will schedule you properly. But then, okay, I can guarantee you that on Thursday at 7, we will have lesson. Okay, so this slot is yours, ne?
Yes, sir.
Yes, and then I will find another slot for you during the week. But then in the meantime, I'll see where can I slot you, and I will also ask Daddy for your availability.
Yes, sir.
Okay.
Yes, sir.
Okay. Bye, Umfuna. Enjoy the rest of the
Bye,
evening
sir.
with the family.
Thank you.
Bye.
You too, sir. Bye, sir.
Okay.